In 1909, Robert Millikan carried out his famous oil drop experiment, in which he determined the charge of the electron. In this experiment, Millikan used an atomizer and sprayed a fine mist of oil into the upper chamber. The tiny droplets were allowed to fall between the two horizontal plates. Millikan observed the spherical drops through a telescopic eyepiece and calculated the terminal velocity of the drops. This terminal velocity is then used to calculate the masses of the drops. The drops were then given a negative charge by irradiating them with X-rays. By applying a voltage to the plates, with the upper plate positive, it was possible to counteract the downward fall of the charged drops. So when Millikan applied the voltage across the plates, it slowed the velocity of the drops. When the voltage is further increased, a few drops started moving upwards. By adjusting the voltage value, Millikan was able to keep an oil drop suspended in air. In this situation, the upward acting force of attraction between the positively charged plate and negatively charged drop balanced the downward acting force of gravity. With the voltage on plates and the mass of drops known, Millikan found out that the charge on a given drop was always an integral multiple of 1.60218 into 10 to the power minus 19 coulomb. He assumed that the smallest charge was the charge on one electron. Substituting the value of charge on an electron into the Thomson's charge to mass ratio gives the mass of the electron. The mass of an electron thus calculated is 9.1 into 10 to the power minus 28 grams. Thus, an electron has charge equal to minus 1.602 into 10 to the power minus 19 coulomb and mass m equals to 9.1 into 10 to the power minus 31 kilograms.